Hello everyone and welcome to my channel, Werner on Security. In this video I'm going to show you how to solve a web exploitation CTF challenge from picoCTF 2021. The challenge is called cookies. I've summarized the most important information about the challenge on this slide. The task is to figure out the best cookie. You'll also find the link to the challenge in the video description below. Here is the challenge that we'll try to solve. Who doesn't love cookies, right? Let's start the application. Let's open the developer tools and the storage tab. Let me zoom in. Here we can inspect the cookies as we use the application. As we can see, we have a cookie with the name and the value -1. Here is the cookie search page where we can enter different cookies. I guess we'll start by searching for the suggested cookie snickerdoodle. That is a cookie, not very special though. Okay, so this doesn't seem to be the best cookie, which we are looking for. Looking at the HTTP cookie, we can see that name now has the value 0. It was previously -1. Let us try some other cookies. I'm not very good with cookies, so let's see if we can find some cookies on Wikipedia. Let's start and try AlphaJur. That wasn't a valid cookie apparently. We can see that the value of our HTTP cookie is back to -1. Let us try with another cookie from the Wikipedia page. I think I'll go with fortune cookie. Maybe it contains a prophecy about our web hacking skills. It seems like we got a similar result as for snickerdoodle earlier. The application recognizes the fortune cookie, but it's still not the cookie we were looking for. Let's check what happened to the HTTP cookie. It now has the value 20. I'd guess that each cookie which the application recognizes has its own HTTP cookie value. So we should be able to enumerate the best cookie by changing this value. Before trying to find the best cookie, I'll give a brief background to HTTP cookies. First, we need to talk a little about the HTTP protocol. HTTP is called a stateless protocol because each command is executed independently, without any knowledge of the commands that came before it. This means that the server does not store client-specific server state, known as application state. Since the server doesn't store client-specific state, this needs to be done by each client. The implications of HTTP being stateless are that it requires more work to maintain state information between requests. This is typically done using cookies. A cookie is a piece of information stored on the client, which gets sent back to the web server on each request. There are two HTTP headers involved in the handling of cookies between the client and the server. First, we have the response header, setCookie. A cookie is saved in your web browser when you receive a setCookie header from a web server. With every further request your web browser makes to the web server, it sends the cookie data back to the web server in the request header cookie. If you want to learn more about these HTTP headers, I've added links to the MDN web docs in the video description. Let's see how this works in the cookies application. Let's start over fresh in a private window without any cookies. We enter the URL to the application and hit enter. We can see that we have the cookie value -1 again. Let's have a look at the requests. So we switch to the network tab. So this is the first request that it gets sent. Here we can see in the response header that we have the set cookie header. This header is sent from the server to the client in the first response. And we see here that the value is -1. When we look at the request headers, we don't see the cookie header there, since it hasn't been set until we get the response from the server. So let's check the next request. When we look at the following request, the request header cookie is included as part of the request from the client to the server with the value -1. As we saw earlier, we found one sugary cookie which had a HTTP cookie value of 0, and we found another one which had the value of 20. We could try to find the best cookie manually by testing each value like this. So let's change from -1 to 10 perhaps. But this will be rather tedious, since we likely need to test for at least 20 values. Let's use a tool to automate this instead. The man-in-the-middle proxy that I'll use for trying out a range of cookie values is OWASP ZAP. Let's enter the URL that we want to explore. Then we click Launch Browser. This launches Firefox and navigates to the entered URL. Now we want to trigger the HTTP request that we want to test for. So let's search for fortune again. Let's go back to OWASP ZAP and see what happened. So here we see the request that got triggered when I click the search button. We are interested in the next request, which checks if we found the best cookie. We see that the cookie header is sent with name equals 20. We want to automate the testing of different values for this cookie. We right-click the request, and then we select Attack, and we can use the fuzzer. In the tab Fuzz Locations, we select the cookie value 20. Then we click Add. We click Add again, and we use the type numbers. And then we enter the values that we want to test for. So let's start from -1 and go all the way up to 40. And let's increment by 1. We can click the Generate Preview button to see the payloads that will be used. That looks fine. Let's click the Add button and confirm by clicking OK. Now we are ready to start the fuzzer, so click Start Fuzzer. Here we see the results. Let's see if we can find a request where the size of the response body differs from the rest. So we see here for the value -1, we only get 209 bytes, which is expected since that cookie wasn't found. Let's continue scrolling downwards here. We see that they all have status 200 OK. Oh, here we see that the size of the response is quite different. So let's check the HTML of the response that we got. So we have the cookies page. Here we see that we have retrieved the flag. Let's copy this and let us put this into the submission form and submit. Hooray! So we solved the challenge and earned 40 points. The technique that we use to retrieve the flag is called cookie manipulation. Now that we have solved the challenge, let's summarize the main lessons learned. We have covered 3 topics related to web exploitation: HTTP, which is a stateless protocol, HTTP cookie headers, and lastly, cookie manipulation. HTTP is called a stateless protocol since each command is executed independently, without any knowledge of the commands that came before it. This means that the server does not store client-specific server state. To overcome the limitations of using a stateless protocol, HTTP implements cookie headers. These are used by the web server to save information in cookies in the web browser. The web browser then includes this information in the following requests. Attackers can easily modify cookies either within the browser or by implementing client-side code outside of the browser. In our attack, we use the man-in-the-middle proxy to modify the cookie. If cookies are not validated and checked for integrity, attackers can bypass authentication, conduct injection attacks such as SQL injection and cross-site scripting, or modify inputs in unexpected ways. This is why it's important to be aware of the risks associated with cookies and to take steps to protect your data. These are some of the basic concepts and skills that you need to know if you want to get into web exploitation. Of course, there is much more to learn and practice in this field, but I hope this walkthrough has given you some useful insights and tips on how to get started. If you haven't already, I definitely recommend you join picoCTF today and continue your learning. If you have any questions or feedback, please feel free to add a comment below. And don't forget to like and subscribe if you enjoyed this video. Stay tuned for more videos on CTFs and other security-related topics. Thanks for watching, and I'll see you next time.